This lesson is on 8-2, factoring using the distributive property. So, factoring using the distributive property is actually the opposite of using the distributive property. If you remember, take something like 2a times 6a plus 8. What we did here was we found the product of these terms by using the distributive property. We did 2a times 6a to give us 12a squared. Then we did 2a times 8 to give us 16a. We'll be using the opposite of the distributive property to factor 12a squared plus 16a. So in order to do this, we look at both of our terms and we find our GCF. The GCF, or greatest common factor, is the greatest number that our two terms, or three terms or four terms, the greatest number that they have in common. So the biggest factor that our two terms have, 12 and 16, can both be divided by 4. And they both have an a. So we'll be taking out 4a, and we'll have something left in our parentheses. So 4a times what would give us 12a squared? Well, 4 times 3 would give us 12, and a times a would give us a squared. So 4a times 3a gives us 12a squared. 4a times what would give us 16a? Well, 4 times 4 would give us 16. 4a times 4 would give us 16a. To check your answer, you should always find the product or do out the distributive property. So 4a times 3a gives us 12a squared, and 4a times 4 gives us 16. So this is how we factor something using the distributive property. In example 1b, again, we'll be factoring this by using the distributive property. We have three terms, 18, 12, and 9. What's the greatest common factor of these three numbers? Our greatest common factor is 3. Both 18, 12, and 9 can all be divided by 3. We also have to look at the variables. We have a C, 2 C's, and 1 C. So they all have at least 1 C. Then D squared, so we have 2 D's, 1 D, and 1 D. So they all have at least 1 D. So our greatest common factor is 3CD. Now, since we started with 3 terms, our answer will be a GCF times 3 terms. 3CD times what would give us 18? Well, 3 times 6 gives us 18, and we took out the C, and we took out one of the D's, so 6D. Just check your multiplication to make sure it works right on each one. So 3CD times 6D does in fact give us 18CD squared. 12. 3 times a positive 4 gives us 12. We take out a C, and we'd have one left, and we took out the D. So 3 times 4 gives us 12, C times C gives us C squared, and we also have the D. 9, so 3 times 3 gives us 9. We take out the C and we take out the D. So 3CD times 3 would give us 9CD. In order to check your work, you're just using the distributive property. 6CD times 6D gives us 18CD squared. 3CD times 4C is 12C squared D. 3CD times 3 would give us a positive 9CD. So we know we factored this correctly. When factoring using the distributive property, we can take a GCF out of any number of terms. So in this problem, we have 4 terms. We can try to see if we have a GCF. However, once we get 4 terms, we can use a process called factoring by grouping. We can rearrange our 4 terms in any order we want. The process of factoring by grouping is that you take the first 2 terms and you group those 2 together. And you take the second 2 terms and you group those together. Out of the first 2 terms, you'll take a GCF out. 4AB and 8 are both divisible by 4, and they both have a B. 4AB divided by 4B would give us A. 8B divided by 4B would give us 2. We'll do the same thing with our second parentheses. 3A and 6 are both divisible by 3. 3A divided by 3 is A, and 6 divided by 3 is 2. In our final answer, we'll be taking our 2 GCFs and putting them together in a parentheses. We have a 4B and we have a positive 3. In our second parentheses, we should have our common term. Basically, when you do this, your 2 parentheses right here should be exactly the same, which they are. So our second parentheses will be a common term of A plus 2. As always, you should check your work by finding the product of your 2 binomials. 4B times A is 4AB. 4B times 2 is 8B. 3 times A is 3A, and 3 times 2 is 6. This is the same as our original problem. So we know that we factored our polynomial correctly, and our answer is 4B plus 3 times A plus 2. Do that in a different color there. So this is our answer. In example 3, we'll be factoring using the distributive property. Again, we'll be doing factoring by grouping because we have 4 terms. So remember that when doing factoring by grouping, you can rearrange your terms in any order you want. So for example, I can rearrange this so it's 35x. Then I'll have the positive 3y. Then I'll write the minus 5xy. And then the minus 21. You can choose how you want to rearrange this. In your factoring by grouping, you take your 4 terms and you group the first 2 together and you group the last 2 together. I would rather, as you notice, 35 and 3 don't have a common GCF. So I would rather keep this as 35x and a minus 5xy because 35 and 5 are both divisible by 5. And they both have an x. So my GCF is 5x. 35 divided by 5 is 7. 5xy divided by 5x is a minus 1y. 3y and a negative 21 are both divisible by 3. When I do this, I'll be left with 3y divided by 3 is y. 21 divided by 3 is a negative 7. Now, in order to do factoring by grouping, my parentheses have to be exactly the same. And right now, my parentheses aren't. So I'll have to do something to fix this. What I'll have to do is go back into my problem and rearrange the order of my second parentheses. So in my second parentheses, I'll have to change this to a negative 21 and a positive 3y. What this does is they're both still divisible by 3, but when I see a negative 21 as my first term in my second parentheses, I'll have to pull out a negative 3. Negative 21 divided by negative 3 is 7. And 3y divided by negative 3 is negative 1y. Now our parentheses are exactly the same. Our final answer will be 5x minus 3. Remember that you put your two GCFs together. And in our second parentheses, we'll have 7 minus 1y, our common term. We should always find the product of our answer to make sure that we did this correctly. So 5x times 7 is 35x. 5x times a negative 1y is negative 5xy. Negative 3 times negative 7 is negative 21, and negative 3 times negative 1y is a positive 3y. This matches our original problem of 35x minus 5xy plus 3y minus 21. So we know we factored correctly.